Welcome to the Aptiv Edge, a TTI podcast discussing the role of Aptiv's broad suite of products in electronic systems from the highway or the factory floor to low Earth orbit and everywhere in between. And now, let's hear from the experts from Aptiv and our TTI specialists.
Thank you, Jim. Hello, everybody. My name is Gabe Osorio, Director of Transportation Marketing for the Americas for TTI's Transportation Business Unit, and your host for this inaugural episode. I'm excited to welcome Nityesh Bohidar, Senior Application Engineer from Aptiv. Welcome to the show, Nityesh.
Hey, Gabe.
Why don't we start just by having you tell us a little bit about your professional background and your current role at Aptiv?
Yeah, so my name is Nityesh Bohidar, and I'm a Senior Application Engineer at Aptiv, focusing on new market growth. My role is to work with our partners like TTI to understand customer needs and provide them solutions in electrical system and the interconnect space. I've spent almost a decade in the industry designing and validating products in power, signal, and data systems. And I'm excited to be here and talk with you today.
Excellent. Thank you, Nityesh. Glad you're here. Today, we're going to be focusing on a 48-volt electrical architecture, and specifically why is transportation, automotive industries moving to this 48-volt architecture. So, Nityesh, first question I got for you. In your opinion, why is the automotive and transportation industry as a whole considering this shift from a 12-volt traditional architecture to 48-volt architecture?
Yeah, and when we look at it, the automotive industry has been historically tried to stay on the forefront of reliability, technology, and customer experience. So shifts in technology happen all the time. In fact, we saw something similar, a similar switch occur in the early 1950s, and that's when the automotive industry transitioned from the 6-volt system to the 12-volt systems that we have had for decades now. So coming back to today, with all the added features we want in our cars, the power demands of our vehicles has been steadily increasing. In fact, since the 1950s, they've increased by over 650%. And that kind of surge in power strains the current 12-volt systems, making higher voltage systems the next logical step by reducing current, enabling thinner wires, and improving system efficiency.
Sure, that makes a lot of sense. When you say higher power demands of vehicles, does that mean they're actually, these applications or these new devices coming into vehicles are requiring more power, or is it something else?
That's exactly it. And we see that with all the new features we have in cars today. So cameras, radars, infotainment. And as these systems used to be mechanical, they're now shifting to electrical loads. So newer systems like steer-by-wire, brake-by-wire, adjustable suspensions are all contributing to this increase. And the electrical loads on today's vehicles are somewhat strained.
So, for example, digital instrument clusters, new infotainment centers, even autonomous driving applications, all that kind of thing, driving more power demand from the vehicle itself and resulting in a higher power strain or higher power need for the vehicle itself, I assume.
Yep, exactly.
And with this 12-volt system that we use today or that's predominant today, are there limitations in today's vehicles because of it?
Yes, and that's where the shift comes from. So those 12-volt systems, require much thicker conductors to handle the higher current needs. And that, in fact, leads into added weight, cost, and packaging complexity. So the constraints negatively affect, what's important to us, which is things like fuel economy, EV range, and cabin space. So the larger the electrical load, the larger the wires need to be at any given voltage. And that's where there's a benefit to moving to the higher voltage systems.
And to be clear, it's not just electrification of vehicles that would drive this move to 48 volt, correct? This would most likely be happening even without hybridization or electrification regardless. Again, back to the added amount of constraint on power based on new and more electrical devices within a system or an architecture.
Oh yeah, every car on the road today could probably see a benefit from moving.
Yeah, okay, that makes sense. So speaking of, some of the advantages then of moving to 48 volt, what are some of those kind of key advantages or key reasons for the change?
All right, so I'm going to take us back a little bit to our physics textbooks. So compared to a 12-volt system, a 48-volt system reduces current by a factor of 4, allowing for smaller wires and terminals. And that leads to lower weight, reduced copper usage, and like I said, it has those improved packaging benefits. So the smaller cables are easier to package, not just by virtue of being smaller, but also because they're more flexible and can be routed a little bit easier. So they can be bent around and optimized, which really helps in today's vehicles.
You mentioned reducing, Nityesh, the current by a factor of 4. Are there other impacts of doing that?
Yeah, so Watt's law, right? That relates power, voltage, and current. So what Watt's law is telling us in this context is, the other advantage of moving to 48 volts is improved power efficiency in the system. A 48 volt system has up to 16 times less power loss due to resistance. And that's because power loss is driven by the square of the current being carried. And I know we're getting really deep here into the math of it, but really all we have to think about is a 4 times reduction in current turns into a 4 squared or 16 times reduction in power loss.
Which is pretty considerable. Is 48 volt then considered safe in terms of electrical hazards then?
So 48 volts is considered the nominal standard, and 60 volts is generally accepted as safe from shock and electrocution hazards. So with some limits around operating conditions, it's kind of the blanket statement that's accepted in a few different industries.
Makes sense. So where does the 48 volt come from then?
So in the real world, once you account for some variations around nominal voltage, some spikes, and some safety factors, 48 volts is typically nominal voltage that keeps your system always below that 60 volts. That's why 48 volts we consider kind of that sweet spot, right? Lower voltages will be less efficient, and higher voltages bring in additional safety concerns.
Yeah, absolutely. And correct me if I'm wrong, but 60 volts is the industry standard for kind of moving to the orange connector, correct? Or is it a little bit higher than that or right around there?
Yeah, as we get into the higher voltages, there's all sorts of different color combinations that come in. And orange is typically, the highest and the safest standard.
Yep, absolutely. Calling to the fact that, hey, there's high voltage or high amperage running through this interconnect system and to be treated as such, basically.
Correct. I always think of it as the orange catches your eye.
Exactly. Yeah, especially for safety and whatnot. Well, good. So it sounds like obviously there's a lot of benefits to moving to 48 volt systems. So is it feasible then that all vehicles are going to make this switch to 48 volt in the future?
Not necessarily. Low power devices like, a lot of our current infotainment and sometimes, lighting, that might stay at that 12 volt system that we have today.
And why is that? Is that just an efficiency thing or is there a different reason for keeping 2 separate systems within a vehicle?
It's more of a real world scenario and situation. So, once the power loads get small enough, the wire size starts to be driven more by making sure that the wire is robust enough not to break. So when you hit these minimum wire sizes, there really isn't the same benefit of changing to 48 volts because your real world mechanicals and electricals won't let you go to a smaller wire size.
Sure. Do you have a potential good example of what that might look like?
Sure. Let's take, for example, interior lighting and LEDs that run at comparatively low power. That system might already be connected with something like a 22 gauge wire, which is pretty thin. Mm-hmm. Going to a 48 volts doesn't really give you as much benefit because let's say you go to a thinner wire, 28 gauge. That's not really robust enough for something like an automotive spec. So that's just one example, but there's, multiple similar cases.
I would imagine the complexities of manufacturing as well, too. So actually populating wire and putting terminals onto those, et cetera, at that small of a wire becomes much more complicated, expensive with tooling and all that other implications as well, too, I would imagine.
Absolutely. They're very small and, delicate wires when you get up to those higher gauges.
So then what happens to the electrical architecture?
So resulting in, having a little bit of a constraint on those low power devices, a multi-voltage architecture is most likely going to exist. High power loads like motors, compressors, suspension and braking systems might see moving to that 48 volts, while low power devices might stay at the 12 volt.
Do you think that there are specific, I'll say, vehicles in transportation that are more ripe for 48 volt transition? Say, meaning, I know we've kind of talked automotive here quite a bit, but what about commercial vehicle or off-highway construction ag? Would those make more sense not having potentially as much infotainment, et cetera, involved in them?
Yeah, definitely. I still see some reason why we'll have a multi-voltage architecture.
Sure.
But the power demands of those industries can be pretty severe. And so, moving to 48 volt definitely is logical.
So, it seems like we've been talking 48 volt my entire career. and it always seems to be on the horizon. Why hasn't the industry already made the switch to 48 volt?
Yeah, so our current 12 volt system has been standard for over 70 years, and that's built an ecosystem around it. When we talk about manufacturing, like you mentioned, things like that, moving and transitioning requires rethinking design, safety, and that manufacturing process.
So a significant amount of brain capital, expense in redesigning new architectures, et cetera. Sure sounds like a lot of investment, both dollar and time, for companies to make that change.
Oh, yeah, it's a system upgrade.
Yeah. So is there more to changing the system than just these interconnects? I would imagine there is.
Yeah, it's not just the connectors, but it's also the devices that are using the power. So the industry will need some time to get these devices updated to operate at that 48 volt.
Makes sense. And for Aptiv specifically, how do you guys see the change happening for you? What does that timeline or arc look like for you guys?
Yeah, as most things in the industry, it'll change when it's economical. So to make this cost effective, we need to get up to scale. And that means we need a large number of vehicles to switch. When that happens, we'll start to realize the real cost savings of that 48 volt architecture. And we're confident that efficiency that 48 volts offers will make it happen. But the timeline to switch is a little bit uncertain.
Yeah, that certainly makes sense. As is many other cases with especially connectors, as the automotive industry has adopted and proliferated use of them, it brings that economies of scale into place where it allows for proliferation to other, I'll say, transportation segments as well too, like construction, farm and ag, heavy truck, off highway, all that kind of good stuff. So it's good to see some examples of that starting to take place. I know we'll talk about in a coming episode as well too. So, and specific to Aptiv, what role do you guys believe you'll play in this transition to 48 volt?
Our components make sure that the OEM can deliver that 48 volt power safely throughout their vehicles.
Excellent. Thanks for being here today. Really appreciate the insight into understanding more about 48 volt architecture and what that's going to look like moving forward. Please make sure you guys stick around. Check our website for our next episode. We'll have Nityesh here again, where we'll be discussing design considerations, looking at 48 volt architectures. Thanks for being here, Nityesh. Appreciate it.
Thanks, Gabe. Thanks for having me.
Thank you for joining us today on the Aptiv Edge, a TTI podcast where we discuss everything from Aptiv's broad suite of products. For more information, visit TTI.com.